Hello, this project is for 2021 fall Hack-A-Roo. Project title, Lunar Lander Problem using Deep Q Learning Neural Network. Here, I try to solve Lunar Lander problem provided by OpenAI Gym using Deep Q Learning Neural Network. As you can see in the picture, we use reinforcement learning to land the lunar lander in between the two flags. We get a positive reward if the lander lands in between the two flags, which is a landing pad, and we get a negative reward if the lander lands outside the two flags. DQN algorithm. Deep Q learning neural network is used here to calculate the action at each step using the OpenAI Gym. OpenAI Gym is an environment that we use here. And here, the observation space are the coordinates and the action that takes place by the lunar lander in each frame are 4 actions. I have also used double DQN to evaluate the original network. This solves the overestimation problem. As you can see here, we have an environment which is the OpenAI Gym lunar lander, and then an agent. Here, the agent is Deep Q Learning Neural Network, where we combine Q learning with a neural network. So, the environment gives the reward and state to the agent, and the agent gives the action back to the environment, where there are 4 actions that can take place. Here, there are 4 actions that can take place for the rocket, that is move left, right, and down, and then do nothing. And as you can see in the picture, here is the landing position, which is the landing pad. Coming to the data, we generate data using environment for the simulation. Here, the landing pad always starts at the coordinate 0, 0. These are the first 2 numbers in the state vector. Here, we give reward to the agent based on the position of the rocket. If the rocket is moving from top of the screen to the landing pad and speed is 0, we give 100 to 140 points. And if the lander moves away from the landing pad, the reinforcement learning gives a negative reward to the agent. And then the episode finishes if the lander crashes or comes to rest. If the lander crashes, we give an additional minus 100 points. And if the lander comes to rest, we give plus 100 points. And then we give each leg ground contact, that is for the each leg left and the right one, plus 10 points for the contact to the ground. And then for firing the main engine, we give minus 0.3 points for each frame. So the solve is 200 points. Landing outside the landing pad is also possible. And here we consider the fuel is infinite. So the agent can learn to fly and land on its first attempt. Here there are 4 discrete actions available, as I have mentioned above: do nothing, fire left orientation engine, fire main engine, fire right orientation engine. I have used Python to train this reinforcement learning. This requires Python 3 or above. The code is tested on Spider IDE. And then here is the neural network I have used with the Q-learning, and then the hyperparameters and the values which I have tuned for the network. So what is Q-learning? Q-learning is used to select optimal action selection policy. So it decides what action to take in next place. Here, the agent learns function that predicts reward of taking an action for given state. And neural network approximates this function. As you can see here, this is the function for Q-learning. Observation space. So here, the state space is 8 dimension. We have X position, Y position of the lander, X velocity, Y velocity, lander angle, angular velocity, right leg grounded and left leg grounded. We give this state space as input to our neural network. And here, environment variables. Coming to the environment variables, we have state, which is the current state of the environment, which is 8-dimensional state space, and then action, where the agent acts based on the current state, and reward if the lander crashes or comes to rest. The episode is considered complete and receive reward. Here, the maximum episode count is 2000, and stopping criteria is if the average reward is of 200 for last 100 episodes. So here, the 8-dimension vector is given as the input to the neural network. A neural network gives the output to the environment: do nothing, fire bottom, fire left, or fire right. These are the 4 actions that may take place based upon Q-learning with deep neural network. Coming to the results, the graph shows the rewards obtained at each training episode with early stopping. As you can see here, the training stopped after reaching 200 reward points. Here, the blue line shows reward values per experiment, and orange line shows rolling mean for the last 1000 episodes. Reward is positive after 300 episodes. Here, while training this model, the agent takes more time to train, and then we can improve the neural network model accordingly to solve the agent in less time by tuning the parameters in it. I have used different parameters values to see how the training change over time. Extension to deep Q learning is double Q learning, where we use 2 fully connected layers. In the deep Q learning, we only use a single fully connected layer with the Q learning. But here in the double Q DQN, we'll be using fully connected layers. As you can see here, I extended the existing neural network using 2 different functions, function approximators that are trained on different samples. So one of the fully connected layers is used for selecting the best action and the other for evaluating the value of this action. Since these two approximators have seen different samples, it is less likely that they overestimate the same action. Hence, we get the name double Q learning as we use two fully connected layers. Coming to conclusion, the experiments conducted as part of this project solve the lunar lander environment using DQN algorithm. It is observed that the weight propagation parameter and weight decay parameter has significant impact on the learning performance. One major disadvantage for environments like lunar lander from OpenAI Gym is that it ignores weight of the fuel used, and it is a two-dimensional simulation of 3D environment. But we can map 2D environment to 3D environment simulation so that we can simulate an OpenAI Gym interface for reinforcement learning and use the parameters and the values that we get in real time to land a real lunar lander on a moon. Thank you.